Hi everyone, a very warm welcome and good afternoon. So how's it going, right? I'm sure you have all have had your lunch and we are in Pune and it's 2 to 4. So please don't go to sleep guys, keep up, catch up with the rest of the talk. So today we are going to talk about building AI-powered applications and how we can achieve that using Couchbase. So very excited to introduce Couchbase and some very core concepts with you all. A little bit about myself. My name is Kavya Parag, and I work as a solutions engineer at Couchbase. Prior to this, I have been working with a lot of customer success stories in my previous stints. So you can scan this QR code. It has some YCSB benchmarks that talk about different database comparisons. So if you want to explore how databases perform, this is a benchmark tool that has all the reports. So please feel free to scan it. I'll just wait a couple of seconds and then we'll move on to the next slides. Okay, so let's set the stage. I just want to mention that a few takeaways that you'll be having, or you'll be going back home with, right? So firstly, we'll talk about vector search, what vector search means. Let's try to understand that from a perspective of a, let's say, 5-year-old, like right from the basics. We'll also know what Couchbase is, what the differentiated capabilities of Couchbase are, and we'll see how we can build applications using the Couchbase as well as vector search capabilities. And we also have a very exciting lucky draw. So in the next screen, I'm going to share a scanner. Please fill out the details on this form. And at the end of the presentation, I'll run a spin the wheel kind of thing, and 2 lucky winners will have some exciting goodies. So I'll just wait here a couple of seconds and then we'll move ahead. I think let's move on to the next slide. You can grab a quick picture if you're not able to scan it and maybe scan it later on as well. So how many of you have heard of Couchbase? Quite a few hands. And how many of you think that Couchbase is the same as CouchDB? Okay, yeah, so that's a pretty common misconception that people have where CouchDB is the same as Couchbase. It's a different platform, and I hope to clear all those misconceptions today. So to start with, every time you have interacted with a mobile application, for example, you used your phone for face recognition, right? You interacted on LinkedIn. You connected on social media networks. You ordered a pizza from Domino's, or you booked a flight or some travel booking online. All these interactions were powered by Couchbase in the backend. So LinkedIn, Domino's, Louis Vuitton, and Amadeus, a lot of more customers are powering their applications using Couchbase. So this is basically an overview of how things have changed in the last few decades, right? So in the 1990s, that's like a really long time ago, it was all about having hardware systems that you can just, access your applications. It was never about performance, it was more about accessing things, right? Then in the 2000s, we had web applications. Now, with web applications, we were all introduced to browsers like Google Chrome, Firefox, Safari, and so were search terms introduced like Google search, and that still remains. I remember using web applications, and they used to be painfully slow because internet was a big challenge back then, right? But over the years, the need from having a web application to mobile applications has largely transformed. So every website today has a mobile app. We used to access Facebook from our laptops, but today we all scroll content on the phone at the touch of a click. And that brings us to today's era, that is AI-powered applications, where we want quick responses, quick actions, and all of them powered by AI agents. So let's move on. Yeah, so let's start with the basics of a vector, right? Every time we look at a color, we know what the color means. You look at blue, you know what blue means. You look at red, you know what it means. But for a system like a computer, how would it perceive the meaning behind information, meaning behind things, right? So computer understands mathematics, that is what it's good at. And that is why we would store these unstructured data formats or complex terminologies in something called as a vector. Now, vector, it's a three-dimensional space. Like for the simplicity of an example, we're looking at a three-dimensional array, a three-dimensional vector here. And this is our RGB model. That is what TVs have been using all this while, the basic three colors, RGB and B. So you can look at the RGB model example where each axis means a specific color, and together we derive meaning behind this. So it's just a mathematical representation of values stored in an array. Yeah, this is what it basically tries to convey. Now, what is a vector embedding, right? Color is the most basic example. What if I have to store a complex PDF of multiple pages? What if I want to store an image? Or what if I have an audio? How am I going to convey that to something like a computer? So for something like that, I would use an AI model that will basically translate all the unstructured information in a mathematical value. As you can see, the PDF is converted to a float of, to an array of values, and similarly for the other two examples. So when you would feed something like a vector embedding in a computer system, and then it would perceive the information behind it. Let's dive a little deeper in the color example. So here we can clearly see a plot of a three-dimensional matrix where we have three axes, X, Y, and Z. Now if you look at the color navy, we can easily perceive that pointed out right here. We can also look at midnight blue and identify it on a scale, right? But for a computer, how can a computer know that navy blue is closer to midnight blue than it is to violet? So let's see what is the computation that goes behind it. So this is achieved by something called as a similarity search, or you can say nearest mapping or nearest neighbors algorithm, right? So these are the vector representations behind all the three colors, and what the computer is going to do is it's going to calculate the distance between the two or between the three. By this information, it knows that midnight blue is just a 38 metric apart from navy, and violet is much farther. So yeah, so something like similarity search is what goes behind the scenes for a computer to understand the semantic representation of unstructured data. So what are some common use cases where we are using vector search and maybe we are not aware of it? So let's quickly discuss that. The first one is content generation. So every time we have opened an Amazon app in the recent times, when you scroll down towards the review section, you will see that there's a summarized content, like the product is good, but it's expensive, right? It's actually difficult for a human being, or maybe you wouldn't want to go through a list of 50 reviews. You would love something that is summarized for you by an AI, and that is what exactly one of the prime examples of content generation is. Next part is data analysis. So let's consider a manufacturing unit with multiple IoT sensors, and these sensors will store your data, store all the temperature information, vibrations, and information in a data set. Now you already have a data that presents all the anomalies. And next time when your system compares, or next time when your system generates a metric that is closer to the anomaly metric, it gives you a proactive, it gives you an alert that it's time for a maintenance or a proactive measure kind of thing. So that is where you can use generative AI for predictive analysis. The next one is hybrid search. Our search recommendation engines are much more complex than we think of. And I'll cover that in a later example. The last one, as we all know, it's ChatGPT. We all interact with, and we're all very well aware of it, so I'll not highlight that more. But that's a very common use case why people are using AI agents to build chatbots and customer support interactions. All right, so time to dive into Couchbase. This makes me very excited, so yeah. All right, so the first time you all developed an application, maybe this is what it looked like. It was the simplistic view possible of developing some piece of code, deploying it on an infrastructure, and then having a database power it. It's as simple as just setting up an RDS instance or a SQL server that you would want on a cloud or on your on-premise. Very simple to set up, right? But if you have worked on complex applications, or if you know that your applications are going to scale in the future, then this is what your reality will look like. I'm not sure how many of you have actually come across a similar scenario, but this is the truth of all the mission-critical applications that we are developing or we are using. It's extremely complex behind the scenes. I'll walk you through all of these examples. So you developed an app with a basic database requirement, let's say MySQL, right? So you have your relational DB right there. Tomorrow, you want to deliver a better customer experience. So you would want your users to have, you would want your applications to have the caching feature. That is where you would integrate it with something called as Redis. Then, because you want scalable applications, you would want a NoSQL DB to power your application. That is where you would have MongoDB or maybe a DynamoDB, right? Of course, you will install something like a SQL workbench to query, to perform aggregations and joins. Then comes full text search. So full text search is basically trying to map words across different documents, trying to understand the word meaning across different documents, and that is where you would use full text search. Or, for example, if you need to do log analysis, that is where it would come into play. Eventing is basically having a trigger-based condition model, right? So, for example, a user logins to your app, you want to give him a promotional discount. You can set up a trigger, like the moment a user logs in, give him a promotional discount. So for doing something like that, you would use an eventing service, or maybe a AWS Lambda function kind of thing, if that's familiar. Then, let's say you have developed a very large-scale application, you have enough data. Now you want to generate insights based on this data. And for that, you would deploy something like an analytics, Databricks or a Snowflake, or a Google BigQuery, isn't it? And if you have a mobile application, then you have Firebase and SQLite right there. So these are different, isolated, purpose-built databases catering to a specific purpose in this entire stack. Now, what is the complexity behind this? Let's revisit that. Firstly, all of these across different infrastructures, right? Different programming techniques, different SDKs. Then you have to make sure all these applications talk to one another. That is like a more advanced complexity that comes into your system. And what this means is basically it's going to take a lot of time for you to ship production scale applications, because you will lose a lot of time in trying to debug across all these different programming languages, stacks, and databases. And let's talk about the cost, right? Each of them cater to a different licensing model, and the infrastructure costs are always going to be there. So what you are dealing with here is an extremely high level of complexity, and this comes into play as your application scale. What if I tell you that this can also be your reality? So this is basically a Couchbase differentiated architecture. It's a NoSQL platform at the core that where you can store documents in the form of JSON, binary, or string data. But you can also achieve all of these things that are listed here. So I prefer calling it as a well-architected data platform, which is built for your future needs for developing mission-critical applications. So let's take a quick look at the different data access patterns that follow. So you can store your documents in the JSON format, instead of storing it in a rigid schema like a table, row, where you have to follow the schema design. JSON is extremely flexible, schema-less. You can have multiple iterations of changes, rows, columns added, and you don't have to worry about the schema. So that gives you a wide range of flexibility. Next is key value access. Key value access is the most easy and the most performant type of access, where you can just access the entire content of the document based on a key value. Then comes SQL query. Now your question must be, I'm talking about a NoSQL platform. What does SQL have to do here, and how does it play a role? With Couchbase, you can use use the exact same query that you would use on a SQL platform and query NoSQL data. So that is the power of Couchbase, where you have the strengths of a NoSQL platform, and you can also bring in your knowledge of SQL and work very easily with minimum learning that is required. Next is your full text search, which means you can do text-based search, find the meaning behind rank the results, or do natural language processing. All of this is possible with full text search today. Real-time analytics, where you have your transactional as well as analytics in the same platform. A real-world application, your transactional and analytics systems are different. And because the nature of your data is in a SQL format, you lose a lot of time in the entire ETL process. So the data is an added complexity that you don't have to manage here, because all of this stays in the same platform. You can also do time series, eventing, and mobile database. So Couchbase Lite is the mobile database that we have, and it has some very starking features such as offline capabilities and peer-to-peer sync. Now, how is all of this possible in a single platform? That is a very common question, and it's very easy to get intimidated by the wide set of features that you have here. I'll talk more about the performance foundation that helps you achieve extremely high level of performance and scalability. That is because of the memory-first architecture. So by default, every data or every document that comes in Couchbase will go in the in-memory side of things first. So it will be stored in your RAM, and you also have a persistent option where it goes to the disk. So you can configure these levels based on your applications, but this is the factor that drives in the most performance. Then we have Magma storage, which means you can store up to 10 terabytes of data in a single node. We have asset transactions, which means you can define varying levels of consistency, availability across the platform. Columnar storage, again, something that helps you drive your analytics. Active clustering. So the traditional databases, right? They still have a master-slave architecture, where all the requests will first go to the master node, and then they'll be routed to the slave nodes. Now, what happens because of this architecture is all the bottleneck or all the overhead goes on a single node. And then there's latency when these masters talk to the other nodes, right? In Couchbase, every node acts as an active node, which means each node is capable of doing reads as well as writes. Then comes workload tuning, where you can vertically scale your applications, horizontally scale them, and also have disk-based scaling. Now, workload tuning helps you choose the number of services that you want. I'll cover that in a future slide. Geo replication and sync, which is basically powered by the XDCR replication protocol. You can have your active clusters or an active-passive cluster in a different geology, all possible through XDCR. Couchbase can be deployed on your on-premise devices, on-premise servers. We also have a cloud option by the name of Capella, and you can deploy it across Google Cloud, Azure, as well as AWS services. Right? We also have Couchbase Lite, which is a mobile application. All right, let's talk about the workload tuning part, where we dive further into how these nodes are actually constructed, right? So let's imagine this one developer node that has all these services that we saw in the previous slide. So you can do query, indexing, you can store your data in the data service, you have full text, eventing, as well as analytics. Now, if I want to start a production level cluster, does it mean I have to go along with all of these services? No, definitely not. It gives you the complete flexibility of choosing the number of services that you want. So today, if I decide that I want a 3-node cluster with the query, indexing, and the data service, I can get started with something of this scale. And tomorrow, if my application scales, and I want 3 nodes catering only to the data service, that's a small configuration change that you have to do on your database, and it's completely possible to scale. So now, what the management behind this is that, For example, I want general compute for my data nodes. I can do that. If my indexing service is powered by something, requires something more heavy on the disk side, I can do that. For query, I require compute-based nodes. I can even select that. And so on and so forth, I can plan my workloads. So you can scale up a service, you can scale out a service, you can only deploy the nodes that you want. And all of this is possible under a single platform, under a single license as well. So this is a comparative analysis of different query languages. On the left-hand side, we have the MongoDB query language, which you can see is very, very different. It is something that requires you to have a learning curve or, actually sit and go through some learning modules to understand that. In the center, we have relational SQL, something that goes across all your SQL servers, and I'm sure most of you are familiar with. And on the last end, we have Couchbase SQL++, which is exactly, or you can say 99% identical to your 99% identical to your relational queries. So let's take a quick example of how you can power vector search queries with Couchbase. So this is a quick recap. I think we've already discussed all these things, but this is basically talking about the different vectors, vector embeddings, and how you can query data in Couchbase. We'll cover that in the next slide. So I'll give you a more relatable example than the one that's on the screen. Let's consider that you want to search a PDF for all the instances that map to climate change, right? What your regular full-text search would do is it will look for all the occurrences of climate and change, and it will return all the results. So your data must usually have something like a climate or a change, these keywords. Now, if I do the same with vector search, it will map the semantic meaning behind these two words, climate and change. And the results that I'll get in return would be global warming, environmental crisis, as well as climate change. So with vector search, you go more beyond just the meaning of the word or the text of the word and dive on the semantic side of things. Okay, so quick example about practical search applications. Today, when you search something, you're not just going to search for a pair of shoes. We have more complex search queries that run in the back end. For example, I want a pair of shoes that match with the favorite color, with the color of my car. Or I want something that has a price range. And I want a rating of more than 4.5. And I want it delivered within a few days, or some geospatial query that runs in the backend. All these cater to a different nature of query, which is usually difficult to have in a single vector database. With Couchbase, you can do SQL queries, you can do search queries, you can have your vector, as well as geospatial and range queries all in the same interface. So this is basically how the query would look like on the FTS side, where you're trying to find cities that start with S. Then you're trying to find city vectors that are in a certain range, and then you would boost the query using a KNN operator. So I'll talk about the edge computing feature of Couchbase. Let's consider we are all using a mobile application, and we're using it on a smartphone. And this is how the architecture is constructed at this point. So you have dependency on a central node, and you have dependency on some edge nodes. Each of these nodes are running Couchbase servers behind the scenes. What happens when there is an internet outage or a cloud outage, right? The moment I have a cloud outage, I still have compute running at these edge nodes, which means that these computing nodes are still running the queries in the backend, and my application is still does not have any network breakage, and I'm still able to access my application. The next scenario is where even the edge nodes are running into an outage. So in this case, my Couchbase mobile application still has a light embedded database which can basically run my queries even when I lose connection to the server. So I just quickly wanted to demo a app. I'm not sure if I'm able to access the cards. All right, so instead of actually demoing it, maybe I'll carry it on at the booth. So this is a simple intelligence app that you can basically download from your app store. What it does, it scans things, and it's powered by Couchbase Lite as well as vector search. So a common example of this is, for example, you go to a grocery store and your shopping cart has a scanner at the top of it, and you can just scan the items and it gets directly added to the cart. All right, so I wanted to demo it, but I'm not able to access it because of internet connection issue. And yeah, this is what it looks like. You can just scan the app and it will automatically detect the item and it will calculate the cost that's associated with it. And this does not require any internet connection because you're actually storing all the information on your Couchbase Lite mobile app. So this means you can continue using the services in spite of an internet outage. All right, because we are running short of time, I think I'd like to conclude it here. We have a lot of exciting demos, and you can try them out. We recently came up with the Couchbase free tier, and it powers vector search as well. So if you want to get started and try out a few demos, please feel free to scan it. I'll have more information at the desk. So I'm at the Couchbase booth. Please come in and maybe we can do a Q&A there. All right, guys, I think that's been my time.